Hi, it's Moser with one more quick tutorial on changes. Well, okay, changes in ionic radius. So, after watching this video, you should be able to correctly predict changes in the radius of an atom which undergoes ionization. In other words, how does the radius change when an atom either gives up or takes on an extra electron? You already need to know what atomic radius is, as well as what an ion is. So, what's an ion? Well, you should remember that an ion is a charged atom. It's an atom that has either taken on extra electrons or given up electrons, making it positively or negatively charged. And, it may come as no surprise to you, positive and negatively charged ions actually have special names. Positively charged ions are known as cations. And if you love cats, it's easy for you to think, I have positive feelings about cats. I have positive feelings about cats. Cations are positive. Anions are the negative ions. And if you think of anti as being against or having negative feelings about something, that's pretty easy to remember too. So, we're going to look at both the radius changes in cations and anions, but we're going to start off with our cation friends. So we've got here from group 1, lithium, and we also have the lithium 1+ ion. And you'll note that I've drawn the lithium 1+ ion a little bit smaller than the neutral lithium atom. Well, why is that? Remember that it all comes down to forces of attraction and repulsion, and it comes down to whether or not it's a fair fight. In a neutral lithium atom, 3 protons are exerting an attractive force on 3 electrons, so they're evenly matched, there's not a whole lot of shielding, and the radius is what the radius is. It's actually the largest in its period because there aren't a whole lot of sort of points of attachment for the nucleus to pull in on the upper shell. Well, once lithium loses an electron, it's now no longer a fair fight, and 3 protons are exerting an attractive force on just 2 electrons. So the radius actually decreases. The nucleus is able to exert a stronger pull, and it's only now pulling on electrons that are at a lower energy level. They're close. There's nothing on that upper energy level. We've lost an entire energy level, in addition to having a very uneven tug of war. The same goes for beryllium. In the neutral beryllium atom, we have 4 protons exerting an attractive force on 4 electrons, and 2 of those electrons are somewhat shielded by the first main energy level. When beryllium gives up those 2 electrons, not only has it lost an entire energy level, which we could show like that, but the 4 protons are now exerting an attractive force on only 2 electrons, very unevenly matched. So as a rule, the formation of a cation tends to decrease the atomic radius. So now if you were asked to put a series of atoms and a few ions in order, you should know that the cation is always going to be smaller than the neutral atom from which it came. Well, what about these guys? These are the anions, and these are 2 common anions, oxygen and fluorine. And you'll notice that in the case, these have gained electrons. In the case of oxygen, it's gained 2 electrons, and in the case of fluorine, it's gained 1 electron. So you'll notice that I drew the ions slightly larger than the neutral atoms. Well, let's examine what's happening. In the neutral oxygen atom, 8 protons are pulling on 8 electrons, 6 of which are in the upper shell, and have some amount of shielding. But it's got plenty of places to get a grip, to pull in on that. Well, once oxygen takes on 2 extra valence electrons, suddenly we have 10 electrons exerting a force of outward, and the nucleus just can't pull them in as tightly. It's sort of like walking 3 dogs on 1 leash. You can't exert as much force because there are just more electrons, and so the ion tends to sort of fluff out a little bit. In fluorine, in the neutral fluorine atom, we have 9 protons pulling on 9 electrons. But when fluorine gains an electron, you now have 10 electrons trying to be wrangled or pulled back in by only 9 protons. So the radius tends to increase a little bit. For a generalization, the formation of anions tends to increase the atomic radius. That's it. You should just understand that everything we see with atoms and with ions is all about attraction and repulsion and energy. So when we form a cation, we tend to decrease the atomic radius. When we form an anion, we tend to increase the atomic radius. That's it.